All right, welcome to the Explainer. Have you ever really stopped and wondered how your search engine or, your voice assistant actually gets what you're saying? Well, it all kicks off with this super important first step called lexical processing. And today, we're going to break down exactly how it works.
So let's kick things off with a pretty simple question. How does a computer read something like a movie review? And I mean really read it. With all the slang, the typos, the sarcasm, all of it. Turns out, it's a way bigger challenge than you might think.
And right there, that's the heart of the problem. On one hand, you've got human language, which is, let's be honest, kind of messy, creative, and totally unstructured. And on the other hand, you have what computers need. Clean, perfectly organized, predictable data. It's like we're speaking two completely different languages. There's this huge gap we have to cross. So, how do we bridge that gap? Well, this is exactly where lexical processing comes into play. It's the very first step in this amazing field called natural language processing. You'll hear it called NLP all the time. And its whole job, its entire purpose, is to take that chaotic human text and turn it into something a computer can actually work with. Okay, to make this whole thing super simple, let's think about it like this. All that raw text, an article, an email, that movie review we talked about, it's basically like a pile of raw vegetables. You can't just, throw them on a plate and call it a meal, right? Not if you want anyone to eat it.
And that's what lexical processing is. It's all the prep work. It's the washing, the peeling, the chopping. It's all that essential stuff you have to do before any of the real cooking, or in our world, any of the real analysis can even start.
All right, so let's step into the kitchen, shall we? Just like a chef has a whole set of knives and tools for their prep work, lexical processing has its own special toolkit. So let's take a look at what's inside.
At a high level, this whole prep process really boils down to three main stages. First, you've got to chop everything up. That's called tokenization. Then you clean it all up, which we call normalization. And finally, you simplify it all down to the basics, and that's reduction. Okay, first up, tokenization. This is our chopping knife. It's the most basic, most fundamental step, and all it means is breaking a sentence down into individual words or pieces. We call those little pieces tokens.
So, take a look at this. A computer doesn't see data mining is powerful as a sentence. Nope. It sees it as a list of 4 separate items. It's no longer just a string of text. It's now a structured list of tokens. And this is the very first step to making our language make sense to a machine.
All right, next up, we've got to wash our veggies. This is normalization, and it is all about making things consistent. So we do things like make everything lowercase. That way, a computer sees data with a capital D and data with a small d as the exact same word. We also get rid of all the punctuation. The goal here is simple: uniformity.
Now, a big part of that cleaning process is getting rid of something called stop words. Think of these as like the filler ingredients that don't really add any flavor. Words like the, is, and, they're everywhere in our language, but for a computer, they're mostly just noise, so we take them out. It helps the computer focus on the words that actually carry the meaning.
Okay, so the last big prep step is all about reducing words to their absolute core. We do this with a couple of techniques, mainly stemming and lemmatization. And the big idea here is to take all the different versions of a word, like running, ran, runs, and boil them all down to their single root, which is just run. That way, the computer knows all these words are talking about the same basic thing.
And this is where it gets pretty cool. You've got stemming, which is kind of the brute force method. It just chops the endings off of words. So running becomes run, which works. But then you have lemmatization, which is much, much smarter. It actually uses a dictionary to figure out the real root of a word. And this is so important because it knows that the root of better isn't bet, it's good. See the difference? It's about finding the actual meaning.
Okay, so we've done all this chopping, all this cleaning, all this simplifying. You got to be asking, right? Why? Why does any of this prep work actually matter? What is the big payoff here? No, seriously, why go through all this trouble? Well, the answer is simple. Without all this prep, our text is just a meaningless jumble of letters to a computer. But with it, we unlock the power to do some absolutely incredible things.
This is the cooked meal we were talking about. With this nice, clean, prep text, we can finally do the cool stuff. We can do sentiment analysis, to figure out if that movie review was positive or negative. We can do topic modeling to find the main themes in thousands of articles at once. We can automatically classify spam emails, pull out important keywords. We can even build powerful machine learning models.
The prep work, it's the key that unlocks every single one of these things.
Okay, so let's bring it all home. Let's recap the whole journey we just took, from that messy, raw sentence all the way to a clean, structured dataset that's ready for analysis.
So here it is, the full recipe. Step 1, you start with raw text. Those are your raw vegetables. Step 2, you use lexical processing to do all the washing, chopping, and cleaning, all that critical prep work. And that leads to step 3, which is the final cooked meal, the powerful NLP analysis that actually gives us incredible insights. So what's the bottom line here? It's that lexical processing is the real unsung hero of the NLP world. It takes that chaotic, raw text and transforms it into structured data. It slices through all the noise to get to the actual meaning. And maybe most importantly, it is the absolute non-negotiable foundation for pretty much every advanced language technology we use today.
And that really leaves us with a pretty fascinating thought to end on. We've built the tools to let machines genuinely read and understand our words. So the big question now isn't how, it's what. What should we ask them?